Say hello now. Hello.
Hello, ma'am.
Hello. No, you say hello. Someone say hello.
Hello.
I'm not able to hear properly. Siddesh Gajengi, you belong to batch 1, is it? I should remove you from batch 2. Siddesh Gajengi, you're there? Siddesh Gajengi. Dania Khan, are you attending the practicals for the first time? Dania Khan.
No, ma'am.
Hello.
Hello. Ma'am, can you hear me? Hello.
Yes, tell me. Dania Khan.
Hello, ma'am.
Yeah, are you attending the lecture for the first time?
No, ma'am. I attended the practicals.
I don't remember seeing her name.
Ma'am, I'm not able to hear you.
Huh?
Can you repeat again?
I don't remember seeing you.
No, ma'am. I was there in every practical.
This is your second practical you're attending?
No, ma'am.
All the practicals.
Practicals I have not attended, ma'am.
Siddesh, are you there? Okay, I think I'll start. Let the others join in. This is a very difficult practical. Gauss Jordan is over, no? The theory. Gauss Jordan.
Yes, ma'am. It's over.
Hope you can see my screen. So in Gauss Jordan, you are going to find a solution for the given set of equations. All the Gauss methods that you have studied. We will be coding two methods, Gauss Jordan and Gauss Seidel. Okay, so these are the two methods. So basically in Gauss Jordan, is you are going to reduce the upper triangle and the lower triangle to 0. So you will get only the diagonal elements left. You equate the diagonal elements to the RHS and you find the value of x1, x2 and x3. Okay, so this is what you will be doing. I'll write it down here. Rule is to convert the upper triangle to 0 and lower triangle also to 0 and equate the diagonal elements to the constants on the RHS and get the solution for the variables. So it would be something like this. This is your lower triangle. This you will be reducing to 0 and the upper triangle. This is your upper triangle. This also you will be reducing to 0. The resultant would be like this. Okay, now you will equate these two. This is A11 x1 and A14. You will equate, you will get x1 is equal to A14 divided by A11. So you've got the solution. Okay. got the 0, the upper triangle and the lower triangle, and you will equate LHS to RHS. A11 x1 is equal to A14, and from here you will get the value of x1 as A14 divided by A11. The same way A22 x2 will be equated to A24. So you will get the value of x2 as A24 divided by A2. And A33 x3 is equal to A34 you will equate, and you will get the value of x3 as A34 divided by A33. This is what you studied. Everybody studied it in this manner.
Yes, ma'am.
Okay, you have studied it in this manner, everyone.
Yes, ma'am. We studied in this manner.
Yes, ma'am.
Study. Now, the method that I will be using to reduce for coding, when we code the method to reduce this to 0 may be different from what you have studied in theory. Okay, so what we are going to do here, when you are going to code, what we are going to do is, we will get an expression in such a way that A21 minus A21 you will get over here. So that will be equal to 0. Here we will get A31 minus A31. So this will be equal to 0. Here we will get A12 minus A12. Here we will get A13 minus A13. Here we will get A23 minus A23. Here we will get A32 minus A32. So we are going to find an expression in such a way that you get the operands on the left and right of the minus symbol. The operands will be the same. So when you subtract two similar numbers, it will be equal to 0. That will be our aim. Okay, so that's what we're going to do. So here if you see, I've just written it in the matrix form. So this all the coefficients I have written here. So our aim will be to reduce A21 to 0. How are we going to reduce? We are going to multiply and divide something in such a way that I get A21 minus A21. Okay, so first let us see what we have to do. Okay. So let us, please don't bother about all these things. You will only bother about what I am showing. You will just watch. So you see here, A21 minus A1 is equal to 0. So this is what we are going to arrive at. So for that, what should we do? Okay. So what we are going to do is, we are going to use for A21 A21 to 0, we will be using this coefficient. Okay, for reducing A21 to 0, we will be using, this is the second row. Okay, so we will be using the first row values. Okay, we will be using the first row values to reduce A21 to 0. Now, can someone tell me what you do in your theory lecture?
We will make A11 as 1 and then like multiply it and subtract it by A21
What
to
is
make
it?
A21 0.
Can you say once again?
We will make A11 as 1. By that we will make A21 as 0.
A11 as 1.
Yes, ma'am. The diagonal angle.
The diagonal elements you will convert it to some. Is someone else saying something? Hello? Or is it a disturbance from your house? Is this Sweetie, right? Who is this?
Yes, ma'am. It's with
Ah,
you.
yeah, repeat once again.
Ma'am, in theory, we will make the diagonal angles as 1, and by that we will make the other, like diagonal element as 1, and by that we will make the other elements 0.
Okay, you're going to make this the coefficients of no, then how will you get the value of x1, x2, x3? You're going to reduce the elements to 0 by some method, by some multiplication, division, something you will be doing, and then and subtraction, you will be doing these operations and you will be reducing, is it not? Yes or no?
Yes.
Can someone else tell me? PT, you don't say anything. Can someone else tell me how it is done in the theory? So, wait. This is what you are talking about?
Yes, ma'am.
Yes, so you will make, this is what you are doing in your theory, right?
Yes.
Everybody in the lecture,
Yes.
this is what you are doing. Okay, so you will be, this is what she said, the diagonal elements will be made as 1, the rest will be 0. So this will, the coefficient of this will be x1, this, the coefficient, sorry, the variable of this will be x1 and the variable of this will be x2, the variable of this will be x3. So whatever you are getting on the, as the fourth column, you will equate it and you will get the value. That will be your answer. Okay, whatever you're getting in the fourth column, that will be your answer. You see here exactly what is there here is your answer. X1 is 6 and X2 is -1, X3 is -2. Or here they have used X, Y, Z. Okay, this is what you have done in your theory. Now, what you are going to do is when we perform operations in our when we are writing the Scilab code, our aim will be only to reduce this to 0. The coefficients here will be whatever we get by calculation. Okay, so our aim is only to reduce this to 0, and whatever coefficient you get over here, that is not an issue because you are equating it to whatever is there in RHS. So whatever value is there here and whatever value is there here, you're going to divide and you're going to get the value of x, y, and z, or x1, x2, x3. Okay, so this is what you're going to do here. Now, so what we will do here is, please listen carefully. Okay, so our first aim is to reduce this to 0. Okay, first aim is to reduce this to 0. Okay, so we should get something like this, a21 minus a21, only then this is equal to 0. Now, how do we get that is, first we find a constant. Okay, so that is why we have, I have written it as C over here. Okay, so how can we reduce this to 0? A21, we are going to use this first row for that. Okay, for reducing the second row elements, we are going to use the first row. Okay, so first we will find a constant and then we will multiply it by a11 in such a way that I get a21 this side. I should get a21 here. So what should I do for that? First I find the constant. The constant that I find will be a divided by a11. Okay, so this is the constant I find. Now this one, this is the constant I find. This one I multiply by the coefficient of, that is whatever you see in your first row. That is coefficient of the first equation. So a11 is the coefficient of the first equation. a12 is also coefficient of first equation. a13, and this is the constant which is on the right hand side of the equal to symbol. So our aim should be, we should choose this constant in such a way that when I multiply it with the elements which are there in the first row, I get a value which will be reduced to 0. So if I take this as a constant, this and this I will get A21 minus A21. That is equal to 0. Okay. So I should be very careful in choosing this constant. Okay. Shall I repeat again? Did anyone understand this? Hello?
Ma'am, can you repeat?
Yeah, I will repeat. Surely repeat. Any number of times. I want you to understand this because this is the only thing we'll write in the loop and it will automatically get executed. It is automatically done, but we have to write this inside the loop. So our aim is to, first we will see how to reduce A21 to 0. Now, as we saw in this here, how did you reduce this to 0? How did you reduce this to 0? Some multiplication division you have done, is it not? Yes or no? You should associate yourself with the methods you have used in your theory, this one, wait. Here it is straight away now. See here what you're doing. So how are you going to reduce this? You're going to perform certain operations like you interchange the two rows, you multiply a row by a non-zero scalar, some number you will multiply. This is what I am talking about. Multiply a row by a non-zero scalar, some number. Okay, so this is what I am talking about as a constant. Okay, you're going to multiply a row by non-zero scalar, add or subtract the scalar multiple of one row to another row. This is what we are doing. Students, did you do this in your theory?
Yes, ma'am.
Yes, others in the meeting. Sweetie, you please keep quiet. Let the others reply. Yes, others in the meeting.
Yes, ma'am, we have done this.
You have done this. Others. Who's this? Who said this?
Astalakshmi.
Yes, the others. Be present here. It's a difficult program. Once you understand, it is going to be easy. It's difficult to pick up. But once you pick it up, once you understand, you will surely be. Yes, others in the meeting, please wake up. Hello.
Yes, ma'am.
Yes, that was Ajil. What about others? Yes. Others in the meeting, are you all there listening to what is going on? You should remember what you have done in the theory, otherwise it's going to be difficult for you. You must remember what you have done in the theory lecture. Otherwise it's going to be difficult for you. Shall I proceed? Hello.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So our aim is to reduce this A21 to 0. Okay, so first we find some scalar using which you can multiply and subtract and then arrive at 0. Okay, so how will we reduce A21 to 0? It should be A21 minus A21. Only then you can reduce A21 to 0. So our aim is to bring an A21 on the right hand side of the operator minus. Okay, we have to bring in some number over here which is same as this number. okay, which is same as this number, only then we'll get a 0. Okay, so A21 is there with us already. That is, this A21 is here. Okay, minus, we go for finding a constant. There's nothing but a scalar is nothing but one number. One single number is called a scalar. A set of numbers which is of the same data type. For example, whole integer data type. A set of numbers is called a vector. Okay, so a scalar is just a single number. 10 is a scalar. 20 is a scalar. But if I have a set of numbers 10, 20, 30, 40, then it becomes a vector. Of course, identified by a single name. Only then it is called a vector. You use A and you have numbers 10, 20, 30, 40. A of 1 is 10, A of 2 is 20, A of 3 is 30, A of 4 is 40. You call that as a vector. So vector is also called a one-dimensional array. Okay, so this, you should know all this when when you read the books or when someone teacher uses vector, you should understand what it is. Scalar is nothing but a single number. Vector is a set of numbers. And then comes the matrix, which is a row by column representation of numbers. Row by column representation of numbers, you call it as a matrix. So there are certain terms that you should know. So what we have to do, we should find a scalar in such a way that when you subtract, you get a 0. So here, instead of scalar, I am using the word constant. That's all. Okay, so that's why I have used the variable c. So the constant that I should find just like that, I should not find something. I should use the constants that are there, the coefficients that are there over here. So I am using a constant, say A21 divided by A11. Okay, so I'm going to do that. That is the current coefficient I am working with. I am dividing it with the same variable coefficient. This is all x1. Okay, you see here, this is all x1 coefficient. So I'm going to use A11, which is of the first equation. A21 is the second equation because my aim is to reduce this to 0. So I use a constant A21 divided by A11 and I multiply it by A11. Okay, so what will I do for the first term? So that is this one, A21. I have written it this way. This is the constant. So when I take this, this and this is a numerator, this is a denominator. So these two gets cancelled. And what is left with me is A21 minus A21. So now this is reduced to 0. Finish. Now, since I am working in a program or even when you are working in a theory, if I have applied this to one coefficient, I have to apply the same to all the coefficients in that particular row. Okay. So now A21 will be this. What will be A22? This is the second one. What will be A22? A22 minus A2 by A11 into A12. Now I'll be using this one for this. I'll be using this one for this. I'll be using this one for this. Okay. So here you will not get a 0. Some number you will get. It will reduce to some number. Okay. Then what is A23? A23 is what? A23 minus first it is a constant. Constant will not change. A21 by A11 into A13. Okay, so you will get some number. What is A24? A24 is equal to A24 minus A21 divided by A11. This constant will not change into A14. So some number you will get. Our aim was to only reduce A21 to 0 and that is done. Okay, the rest are not, it will not be reduced to 0. Some number you will get, okay? But our aim was to reduce A21 to 0, and that we have succeeded with, okay? Did you understand, students, what's going on here? Everybody?
Yes, ma'am, understood.
Others? I'll repeat it any
Yes.
number of times. I'll repeat it any number of times. B1. Please let me know. I will repeat it any number of times. 1 second, students, I'm coming. So, I'm starting it off again. So our aim is to reduce A21 to 0. So for that, I should get A21 is equal to A21 minus A21. Only then it is going to be 0. So we have to smartly choose some operation so that this is A21. Okay. Now we cannot subtract A21 by A21 directly for all the numbers. Okay, we cannot do that. So what we do is we have to use the rows that are there with us. Okay, we have to use the rows that are there with us. So we are going to use the first row here. We are going to use the first row to reduce the second row to calculate the values of the second row, also reducing A21 to 0. So we will first deal this with A21 to 0. So what do we do? I'm just working with this, okay? So A21 will not change. This is of second row, okay? This A21 I'm talking about is of second row. Now how do I use the first row? First I need a scalar. I'm finding out a scalar. The scalar is A21 divided by A11. Okay, so this is the scalar. So this scalar we multiply by the first coefficient A11. Okay. Now these two gets cancelled and I get an A21 on as the numerator. So I have succeeded. A21 minus A21. So A21 is equal to A21 minus A21, which is equal to 0. I should be smart enough to select the scalar, or here I am using the word constant. It will be constant also. It is a constant. It is not changing on per variable basis. This is not changing for all the for all the elements in the row. It is going to be the same constant. For A22, A23, A24, it is going to be the same constant. So, I mean, it's going to be the same value. That is why we use the word constant. Okay, or you can also use the word scalar. No problem. Okay, so when you are working in theory, you would have when you are working out manually, sir would have used the word scalar. No problem. You can use the word scalar. Scalar is nothing but a number. That's all. Okay. So here, why I use the word constant is because this is not changing per value basis in a row. Okay, it is not changing per value basis in a row. That is why I have used the word constant. No problem. So that is your choice. Okay, you say scalar, no problem. Use the word scalar. That is your choice. So now we have reduced this to 0. Is this clear? Then I proceed further, or I repeat this again. Tell me, students. Everybody in the lecture, did you understand this part?
Yes, ma'am.
Yes, ma'am.
Other than Sweetie and Ashtalakshmi, others.
Yes, ma'am.
Yes, ma'am.
4 of them have said yes, ma'am. Because only if you understand this, I can proceed further. Please put in the chat whether you have understood or not. 28 of you are there. Otherwise, I repeat it again. I can repeat it any number of times. But I want you to understand this, otherwise there's no point in me proceeding further. If you want me to repeat it again, I'll repeat it again. No problem. Yes, students. May you put a message in the chat whether you have understood or not. Yes, 10 of them, 11 of them have given the message that they have understood. What about others? Other than Sweetie, Ashwalakshmi and Ajil, they said yes. They unmuted and said yes. So shall I proceed? Others, those who have not even said yes, ma'am. Shall I proceed? You have to understand this so that I can. Okay. So we have reduced this to 0. Okay, so when we reduce this to 0, we have to apply the same procedure to all the coefficients in that particular row. Okay, so here this will be 0. There is no guarantee that the others will be, what will be the other numbers? It will automatically, after applying the formula, whatever we have applied, you should apply and get. So for example, A22 will be what? A22 minus A21, this is our constant, this is not going to change, okay, into A12. In the first case, here it was A11, so it got cancelled and we got an A21 here. But in the second case, we have to use this. Third case, we'll use this. Fourth case, we'll use this. So A23 will be what? A23 minus A21 divided by A11 into A13. So A24 will be what? A24 minus A21 divided by A11 into A14. So some number you will get in all these three values. Okay. So that is what I have written over here. See the constant A21 by A11. First A21 you are calculating. A21 minus constant is this one. C is this one into A11. So that's you're getting it as 0. Next A22. A22 minus A21 by A21 because this is a constant into A12. In the same way, A23 and A24 will also be reduced. Is it clear, students, everybody? Yes?
Yes, ma'am, clear.
Say yes, ma'am. Just unmute and say yes, ma'am, everybody. It is difficult for me to chat and then
Yes, ma'am.
whether you have, yeah.
Yes, ma'am.
Yes, ma'am.
Say yes, ma'am. That is better, always. Okay. So the same, this has to continue for reducing A31 to 0, A32 to 0, A12 to 0, A13 to 0 and A23 to 0. Okay, so these have to, all these have to be reduced. So every time we should be smart enough to select the constant value. Okay, so now we will go for the code. So actually I have shown what happens in each step here also. I have shown the output also from the program. Okay, what happens in each step. So we'll come to all that a little later. So now, so the first part, that is coding. Okay, so we are assuming we are going for a 3 by 3, three sets of 3 equations. Okay, so we have to handle this. Now you all know how to handle matrix, is it not? Everybody? Yes or no?
Yes, ma'am.
You have 2 loops for matrix. For j is equal to, for I is equal to, or for I is equal to, j is equal to, whatever, however you want, you can write. Okay, so for j is equal to I, for I is equal to, and then the values will be ij. Okay, so whatever is the outer matrix, what does it represent? What is the, sorry, the outer loop represents what? Rows or columns? Columns or rows? Yes, students? The outer loop represents columns or rows. You should know that first, otherwise there is no point in.
Column.
If I have a matrix 10, 11, 12, 13, I have this matrix. I have to read it in Aij. So for I is equal to, I want it as Aij. So I'll have for I is equal to, for j is equal to. It will be 1 to 2. I only have, please forget about the language. If it is language, I mean for you, the C language, it will be 0 to 1. Okay, since you have studied C language, let me go for 0 to 1. 0 to 1, 0 to 1. So you first have to read A00, then you will be reading A01, is it not? Then you will be reading A10, then you will be reading A11. Okay, so hope you all can see my screen. You see here, the 0 is not changing first and 1 is not changing. And how am I reading it as? A, I, J. So you see here, first I is not changing, J is changing. Okay, I is 0, J takes the value 0 and 1. Next, I is 1, J takes the value 0 and 1. So I represents row or column. Is this row or column? This is the simplest thing that I can tell you.
Row.
This is Sweetie who's saying row. Who said row just now? Hello?
Yes, ma'am.
Yeah, it's okay. Someone else try. See, let it be wrong, let it be wrong. Please do not bother. I am not going to say anything. My aim is you have to understand. All will not be correct. No, that is okay. We learn by making mistakes only. We cannot be correct always. We cannot be correct in the first attempt. No problem. Since I have shown you now, this is how you'll read a matrix, yes or no? Students, have you studied this matrix in C language? First you tell that. Did you do matrix addition, matrix subtraction, matrix multiplication in using C language? Did you do that?
We did it, ma'am.
Yes.
One second, one second. Huh. So have you done it? Yes. Yeah, you told me you've done it. So you know that we need two loops to read a matrix. Everybody, why we need two loops? Because we have to keep track of the rows. Now, if we take the first row, then we need to read two elements in the first row. So if we have one loop, we know how to read one dimensional array, we know how to read using one loop. If we have just I is equal to 0 to 2, then I will use AI and I can read one row. Okay, I can read one row. That is, I can read say 10, 12, 11, 20. So this I can read using AI, A of I. Okay, you write it like this, A of I. I can do that. But when there are more than one row, it's not just one dimensional array, I have more than one row, then I cannot go with one loop. I have to go for more loops. Okay. So we are trying with one more loop. So you all know when you have two loops, you will put a bracket like this, you will put a bracket like this for easy understanding. And we write ij here, we close the loop, we close the loop. This is how we usually do. This is how we do. Yes or no? Of course, you will be using scan, ampersand, aij, all that you will be using. Scan f. I am just showing in a pseudocode. Okay, so here I is equal to 0 to 1 and j is equal to 0 to 1. How does it happen in the case of if you don't understand this, I cannot proceed further. First, I will be 0, j will be 0. So now you will read aij, that is nothing but a00 first over. Since this is the outer loop and this is the inner loop, j will go from 0 to 1, this will go to 0 to 1. So now the next loop will be, j will be incremented by 1. I will be 0 only. I will not be incremented. The inner loop will finish its round first and then the outer loop will be executed. So j will become 1. Now the what will be read? I is not changing. So A01 will be read. So this is done. Now since it has exhausted, the j value has reached 1, it will stop. There is nothing more to the condition that you have given in the for loop. As long as j is less than equal to 1, you have given a condition like that. Since the condition is met, when you say j plus plus, j becomes 2. So the condition becomes false. So now it will go to the outer loop and now I will become 1. And again the j loop will start from the beginning. J is equal to 0. So what will be read now? 1, 0 will be read. Again, I will not be incremented, j will finish. So j is equal to 1. So A11 will be read. A11 will be read. Now the j loop has exhausted, the condition is false. So now it comes to I becomes 2. But you have given the condition I is less than equal to 1. You have given the condition for I loop. Again, that condition is false. So it stops. So now after seeing this, what do you think the I loop is representing? What is I loop representing? Or the outer loop representing? Now there should be no doubt. Sweetie, you have already answered. I want others to answer. Now, what do you think the I loop is representing after me showing this?
Row.
Who's this?
I'm Tanya.
Yes, someone else? Someone else tell me what is I loop representing? After me showing this, yes, first you see A00 and hope you all know in a matrix how it is represented. A00, this is A01, this is A10 and this is A11. How did I read first? See here, A00 is read first and then I am reading A01, then I am reading A10, then I am reading A11. This is first, this is second, this is third and this is fourth. Now you tell me I is representing row or column. Not those who... Yes, who is that? Who told me row now? Yes, someone else? Is there any doubt in that now? Why are you all not answering? After me showing this, you should clearly understand what does the outer loop why are you using the outer loop? Why are you using the inner loop? The outer loop represents the row. What these people have said is correct. The outer loop represents the row. The inner loop represents the column. Please clearly understand. Okay. So the inner loop is used to traverse the elements in a single row. The outer loop is used for the rows. How many rows? And inside each row, how many elements? For that you are using J loop. In each row, how many elements? For that you are using J loop. For each row, you are using I loop. So you see here, the first number will be the same in the row. You see 0, 0. Here you see 1. Here also you see 1. If you have a third row, you will have A20, A21. So this 2 is represented by I, whereas this 0 and 1 is represented by J. That is why every time I takes a value, J takes all the values. So when I take 0, J will take 0 and 1. When I takes 1, J will take 0 and 1. When I takes 2, J will take 0 and 2, 0 and 1. Okay, so every time I takes a new value, J travels through all the values. Yes.
Ma'am, for column transformation, it will zero or it will be same?
Column
Transformation.
Column transformation, why you are talking about that here now?
Suddenly it strikes me, that's why.
No. Here I am just making you understand with respect to the language. Okay? When you are talking with respect to any programming language, how to work. That is what I am teaching you now. Okay? Hello?
Okay, ma'am.
Is this clear, students, everybody? Did you understand the loop? What is the use of the loop? Did you all understand? That you should understand so that I proceed. So, if I use, say, for L is equal to 0 to 1, and then I use for M is equal to 0 to 1, you should blindly say, this is to represent the row and this is to represent the column. That's all. Okay, so whatever is there as the outer loop, if you are working with matrix, okay, if you are working with matrix, whatever is there in the outer loop represents the row, and whatever is there in the inner loop represents the column. Okay, the outer loop represents the row and the inner loop represents the column. This much you should blindly register in your mind. Yes, is it clear, everybody? Shall I proceed?
Yes, ma'am.
Others, shall I proceed?
Yes, ma'am.
So now here we have used J as the outer loop and I as the inner loop. So as I said, J will represent the row and I will represent the column. Next, we have used a condition I not equal to J. Why have we used this condition? Because we will not touch these elements. We will not touch these elements. Our aim is to only reduce the upper triangle and the lower triangle to 0. Okay, we have to only bother about these elements. This only we have to reduce to 0. Okay, we should not reduce this to 0. Okay, so that is why, one second. That is why we have given this condition I not equal to J. What do you mean by I not equal to J? Can someone tell me? What do you mean by I not equal to J? Yes, why have we given this condition? After me explaining, can you tell me? So here, this is I and this is J. 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 Okay. So we have to only reduce this part to 0, or we have to make changes only to this part. Okay. So we have to make only changes to. So if you see here, is I equal to J? We know this is I and this is J. This is I and this is J. We know that. This is I and this is J. So everywhere where we have to reduce it to 0, I is not equal to J. So no, students. Whereas the diagonal elements I is equal to J. So we should not touch this. We should not reduce A11, A22 and A33 to 0. So we should not touch that. We should not reduce that to 0. Our aim is to only reduce this to 0. Okay, so we are giving the condition if I is not equal to J, you are going to give the procedure to reduce to 0. Otherwise, we don't touch. Is it clear, students? Everybody, did you all understand why the condition is given as I not equal to J? Everyone?
Yes.
Sweetie and Ashtalakshmi and Ajil, keep quiet. I want others to say. Yes.
Yes, ma'am.
Just unmute and say, otherwise I will once again explain. I'll once again explain. Now, for example, suppose you are asked to find the sum of diagonal elements. Suppose you are asked to find the sum of diagonal elements. What will you do? In C language, what is that you will do? Assume you have scanned the values. This is already done. You have a loop, I loop, and you have a J loop, and this is done. I want only the loop for process. So you will say, suppose if it is a 2 by 2 matrix. Okay. So I is equal to, now you may be wondering why I am writing like this. I less than equal to 1, I plus plus. Okay. And then you will be writing for J is equal to 0, J less than equal to 1, J plus plus. And then what will I write here? Can someone tell me? Assume S is equal to 0 is given over here. What should I write here? I want to find the sum of diagonal elements. So that is
If I equal to J, then we want to submit.
4. I want to find the sum of 4 and 1. Yes. What should I write here?
If I equal to j, then we want to sum.
Yes. If I is equal to j, then I say s is equal to s plus aij. Yes or no? I'll write it like this. I get the sum of 1 plus 4. I'll get in s, if I print s, I'll get 5. Suppose I say find the sum of 3 and 2 non-diagonal elements. What will I write here? Suppose I say find the sum of non-diagonal elements. Non-diagonal elements. What is the change I should make?
I is not equal to j.
So I only have to say I is not equal to j. Done. Okay. So did you understand now why here it is I is not equal to j? In Scilab not equal to is like this. In C not equal to is like this. In Scilab not equal to is like this. Now did you all understand why this condition is given here? Everybody?
Yes, ma'am.
Yes, ma'am.
Others please. This is the simplest way I can make you understand why the condition is like that. So here what is our aim? We have to only reduce the non-diagonal elements to 0. Only have to reduce the non-diagonal elements to 0. We should not reduce the diagonal elements to 0. That is why we have given the condition I not equal to j. Is it clear, everyone? Shall I proceed? See, you have to, otherwise it will be like, what to say, please be active, and especially this program, it's very important for you to be active. Are you all there? "29 of you. Good morning. Get up from your bed and sit and listen to what I'm saying. Is it clear, everybody?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Only the same people, Sweetie, Ashtalakshmi, Ajil, now Ajinkya Gadge also I can see. What about the others? And every time coming to Teams and chat, yeah, every time coming, for me to come open Teams and see, see the chat messages is not, I'm not comfortable with that. Okay. So now, I hope you all have understood. So that why we have used, this I not equal to j. Now we proceed for this. The constant, the scalar, we find the scalar. So what is the first scalar that we found? A21 divided by A11. Okay. So now we have given the condition I not equal to j. So as per, hope you all can see this loop. Okay, so j is equal to 1. I is equal to 1. The condition says if I not equal to j. But here the I is equal to j. So it is false. So now j gets incremented and j becomes 2. Okay, j becomes 2. Now this condition, if I not equal to j is true. So it comes inside. And now I should find this constant A21 by A11. Where is this 2 present? In j. And where is this 1 present? In I. Can you see? In j 2 is there and 1 is in I. Can you all see, everybody?
Yes.
So I'm just writing this in terms of j and I. So 2 is in j. Okay, 2 is in j and I is in 1 is in I. Okay, so ji divided by Oh, I have written, sorry. Oh, I have written it, I thought I is outside. Okay, sorry, but J is outside, no? Usually we write I is outside, so that is why. So J is equal to 1 and I is equal to 1. And we have the constant as A21 divided by A11. Okay, I'm sorry, I wrote I outside and J inside. So I is equal to 1. Now the condition says if I is not equal to J, it is equal. So this is false. So I is incremented by 1. So I becomes 2. If I is not equal to J, this is true. So now we are going to find the constant. So where is this 2? It is in I. Where is this 1? It is in J. This is in J and this is also in J. Are you all accepting this? So we write the equation Aij divided by Ajj. Are you all understanding this constant term, students? Everybody? Should I repeat it again? I'll repeat, no problem. Or is it clear? See, first time what I did, we always have the habit of writing I outside and J inside. I mean, I always have the habit of writing, but this time I just changed it this way, that's all. So purposely I changed it and so I wrote it, first time when I said I wrote I outside and J inside. Okay, so that is why it was seen like that. Yes, is it clear everybody?
Yes, ma'am, it's clear.
Should I repeat it again? Others in the meeting, should I repeat it again? Hello? Hello?
Yes, ma'am.
Should I repeat it again or shall I proceed? Did you all understand this? I'm teaching step by step. Now this is okay, this is okay, this is okay, this is okay. I have finished till here. Now this is 1 colon 3 because you have 3 elements over here. Okay, so that's why it is 1 colon 3. You have 3 elements over here, that's why it's 1 colon 3. Okay, shall I proceed?
Yes, ma'am.
No one is answering. Wow. Fine. I know Speety, Akshalakshmi and Ajil, and also Gadge. I don't know about the others. Okay, these 4 are answering, but others also, please listen. Please do not, when you understand, no, there is no need to by heart. When you understand, there is no need to by heart. By hearting code is not at all is nowhere near programming. Okay, by hearting and programming doesn't go hand in hand at all, these 2 words. You must not by heart programs. Okay, now what we are going to do, next you see a third loop. Now why do we need a third loop? Change the color. Now why do we need a third loop? Why is this loop necessary? So always when you see, even especially in matrix multiplication, you see an I loop, you see a J loop, and then you see a K loop. When we have this, we are to traverse through the elements in the matrix, then why you need a K loop? Okay, suppose you have 1, 2, 3, 4. You have this matrix, and again you have another matrix 1, 2, 3, 4. So how do we multiply the matrix? We always say 1 into 1 plus 2 into 3. Okay, the first row and first column. We take it this way. Okay, so then we get the first element. Now, we have a method to traverse through all the elements in the matrix. We need two loops to traverse through the elements in the matrix. Now, apart from that, in the case of matrix multiplication, it is not the positional. You are not going to use the position to multiply. Okay, for example, when it is matrix addition and matrix subtraction, position 0, 0 element and position 0, 0 element of the second matrix are added. That is this one is added to this one. This is 0, 0 position. This is also 0, 0 position. So that is, so then that you will work with I, j loop. But in matrix, what is happening? The first row in the first matrix and the first column in the second matrix is taken for multiplication. So how do we keep track of first row in the first matrix and the first row in the second matrix? How do we do all this? We cannot work with two loops. We have to go for the third loop. That is what is, we use it as the K loop. So K loop is used to keep track of the first row of the first matrix and the first row of the first column of the second matrix. So that is why you will see when you are multiplying, you will say A I comma K into B K comma J. You will be using this. What does this K represent? This K is representing the first row in the first matrix and this K is representing the first column in the second matrix. Okay, so that is why you have used the third loop K. Okay, so this has nothing to do with the actual position in the matrix. Okay, so the same thing applies here also. Hope this is clear to you, students. Matrix multiplication. Hope you all understood why the K loop was used. Yes or no, students? Everybody? Hello?
Yes, ma'am.
The same thing you have to remember here. K is equal to 1 to 4. Always. Now, what I'm trying to say is, a third loop is always used for something extra that is being applied in our or something other than the positional elements. We are going to handle something other than the positional elements. Then we go for a third loop. So here if you see the K loop is being initialized as 1 to 4. Now why is this 4 seen over here? Because you have the elements on the RHS also being stored in the form of a matrix. This whole thing will be stored in the form of a matrix. So this one, these elements that is in the fourth row, this is what is there in the RHS. Okay, this is what is there in the RHS. So we need this also. We have to apply this reduction that you are the formula that you are applying to A21, A22 and A23 should be applied to A24 also. Okay, so but we have a matrix of size 1, 3 and this is RHS, this is LHS and this is RHS. We need to use A24 also to be reduced. So that is why we have used 1:4. Now we go for reducing. Okay. So we say A of I comma K, I is 1, K is 1. So that is A11 is equal to, sorry, I will be 2. A21 because I is not equal to J is there. So A21 is equal to A21 minus C we have already found it as A21 by A11 into A jk. What is a, j? J is 1, k is also 1. So a, 1, 1. So these two will be cancelled and you will have a to 1 is equal to 0. Okay, so that's what you have written here. Okay, a, I comma k. Where is I? I is equal to 2. So 2, that is why you have written I. K is equal to 1. A, I comma k, a, I comma k minus c we have already found here. So we just say c into a, 1, 1 we need. Where is 1? J has 1 and k also has 1. So we say a, j comma k. That's all. Okay, so I have shown the implementation here. If you see here, you see here j is equal to 1, I is equal to 1 first. See the loop. So if condition fails, I not equal to j, if condition fails. So I becomes 2, j is equal to 1, I becomes 2. Constant I have written. K is equal to 1. So a to 1 is calculated as 0. Then k becomes 2. So a to 2 is calculated as something. When k is equal to 3, a to 3 is calculated. When k is equal to 4, a to 4 is calculated. So all the 4 elements are calculated. This a to 0 will be reduced to 0. This will be something will be done. Some value will be there. Did you all understand, everybody? First loop. Did you all understand? Everybody?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Now we go for the second loop. So first I is equal to 2 and k is equal to 1 to 4 we have done. Now I will become 3. K is equal to 1 to 4. J is still 1 because this condition should fail, only then j will be incremented to 2. So C will be A31 by A11. Please compare it with this. Write this here. Hope you will not get confused because I have written this here. Wait. Okay. So you see here, I is 3, j is 1. So you see A31 divided by j is 1, so A11. So now k is equal to 1, you will reduce A31. This will be reduced to 0. So A31 minus A31 into A11 into A11. So A11 will get cancelled. So A31 minus A31 you get 0. Again you go for k is equal to 2, some value will be there, k is equal to 3, k is equal to 4. When k is equal to 3, A33 will be reduced. When k is equal to 4, A34 will be reduced. Now the condition when you implement I to 4, the condition will fail and j will become 2. So you see j is equal to 2 and again you start from I is equal to 1. The C value will be A12 by A22. So K is equal to 1, something will be calculated. Now, here A12 will be reduced to 0. This one will be reduced to 0. A12 will be reduced to 0. Again, K is equal to 3 and 4. A13 and A14, some value will be calculated. Now, when you increment I is equal to 2, the if condition will fail. Then I is equal to 3 will be done. I will be incremented to 3. And you find the C constant again. A31 is already 0 here. We have already found A31 is equal to 0. So that you are not touching. K is equal to 2. Then A32 becomes 0 now. This becomes 0. Okay. So here, first we reduce this to 0. Then we reduce this to 0. Then we reduce this to 0. Then we reduce this to 0. Okay. It goes column by column. therefore something will happen to this and this. Okay, some value will be written there. Is it clear? Should I, like this it goes on. I was not able to show all the calculations here. I think this will help you. Yes or no, everybody? Hello?
Yes, sir.
Did you all understand?
Yes, ma'am.
Yes, ma'am.
Should I add this here everywhere? Okay, so when j is equal to 3, I have not shown the calculation here. A13 and A23 will be reduced to 0. This one and this one, this A23 will be reduced to 0. Okay, now to see what is happening in this code, I have I have added a print statement over here. Wait, let me add that here. So what I have done is, after this same as what I explained, I just added a print statement to see what is the current j value, what is the current I value, and what is the current k value. Okay, so I have written, you see here, j is equal to and I is equal to k is equal to. I have just added the j, I, k value just to see what is happening in each loop. Okay, and I have printed a of I comma k. I have printed. Okay, this one I have printed this value. See here, I comma k I have printed. Okay, so I have just added a print statement so that I will see what is happening in each loop. Okay, just for that I have added a print statement so that you will also be convinced, okay, this is happening in each loop. So you see here, as we discussed in the previous slide, A to 1 is reduced to 0 first. I have written in green color. All the others, some value is calculated and you get to see the some value over here. Then when I is equal to 3, k runs from 1 to 4. You see here I is equal to 3. And that time A31 is reduced to 0. Okay. Then this is when j is equal to 1 and j is equal to 1. Then j becomes 2 and I loop starts from 1. So when I is equal to 1, A12 gets reduced to 0. Then here I becomes 3 because when I is equal to 2, this condition will fail because we have written I not equal to j. That condition will fail. So I will become 3 and A31 and A32 gets reduced to 0. Then the next round j becomes 3 and when I is equal to 1, A12 and A13 will be reduced to 0. A12 is already 0, so it remains 0. A13 is reduced to 0. Then the next round when I is equal to 2, A21 and A23 will be reduced to 0. A21 is already 0 here in the first round. A23 is the new one that will be reduced to 0. Okay, so this is how it goes. So you have the upper triangle and the lower triangle reduced to 0. You equate the two and you get x of 1. You equate these two. 9 by 3 is 3. Minus 3.7 by minus 3.7 is 1. Minus 12 by minus 12 is 1. So you will get this x of x1 as 3, x2 as 1 and x3 as 1. Is it clear, students, everybody? Hello? Did you all understand?
Yes, ma'am. Yes.
Yes, ma'am.
See, those who are not opening up, please, someone, if they approach you, please do explain what it is, okay, everybody? Please help each other. And when you help each other, you are also studying. You are also studying by teaching others. If you have understood, if someone is approaching you, please don't, please try to help them. Is it clear, everyone?
Okay, ma'am.
Those who are
Yes,
saying
ma'am.
understood. Or you approach me, I don't know whether you will be, if I will tell you, I usually send voice messages. If you, I have never seen anyone asking me doubt, but you can always approach me for doubt. So I'll be sending a voice message so that you will feel I am only talking to you than messaging, and I will make you understand. So you can always paste the code, and sometimes I may, suppose I am busy, I would have seen the message and I would not have replied. You can always ask me again, okay? So I may forget to reply, so please remind me and I will reply. Okay? So please feel free to talk to me. If not me, please ask your friends. Okay? Is it clear, everybody? Everyone? Shall I show the code? You'll write the code. Once you finish executing and once I finish it for the other batch also, only then I'll put this in the Teams. I'll be, this one I will load in the Teams because you have to see this, what is happening. So this I'll be loading in the Teams. How it is actually working, I'll be loading in the Teams. You can take a screenshot of this. This is the code. So you will be working with this data. So hope you all know how to initialize the matrix, everybody. Each row will be separated by a semicolon in Scilab. How will you initialize the matrix? You all know, everybody? Hello?
Yes, ma'am.
So you can work with the system of the equations that is being given in the theory lecture also. I have given two examples here. I have given two examples here. One is this and one is this. So you can test whether you are getting the correct output. Yeah, this part. Sorry, I forgot to tell this part. So how will you equate this? I only finish with this. Okay, I only finish with this part. Oh, sorry. I only finish with this part. I am yet to explain how to equate. So now you have got the values in AI, comma K, you have the values. Okay, all the values are there. Now we have to use this loop. This is an easy one. For I is equal to 1 to 3, you are going to calculate x1. Okay, see x of I. Calculate what is that? A14. You see here AI comma 4 divided by AI comma I. That's all. That is all. So when I is equal to 1, it is AI comma 4 divided by AI comma I. And when I is equal to 2, it is AI comma 4 divided by AI comma Y. 2 comma 4 and 2, 2. And 3 comma 4 and 3, 3. You get the values of x of 1, x of 2 and x of 3. Okay, friends? Hello? Hello?
Okay, ma'am.
Here, this is easy. We have to use 4 because that is the RHS. We have to explicitly say 4. Now, if you have an equation with more than 3 variables, then here you will write I comma 5. If you have an equation with 5 variables, here you will write I comma 6. That's all. Only that much change you have to make. So this 4 we explicitly write because everywhere it is 4. It is not changing. But others are changing. In the first time it is 1, then it is 2, then it is 3. But this 4 is not changing if you see. Okay, so we are writing it as 4 straight away. Okay? Is it clear, everyone? Hello?
Yes, ma'am.
Yeah, this loop is to, this one why I have written is, you see the previous one, wanted this output. I wanted to see the actual position of the 0 and the for this this loop is written. Loop is for that. This one is for that. I have written here capital E. Now you don't write capital E. It's small. Wait, I am showing it, and please take. This is your actual code. You can take a screenshot of this. Everybody. All know what is this 5.2? Have you all taken the screenshot? Everybody?
Yes.
This 5.2 stands for what? What is this 5.2? What is 5.2? Yes, students. So that is usually given for floating point numbers. Now suppose we have a large number. Usually, suppose you have a number 123.456. Suppose you have some numbers like this. You want to represent this only in. You want only two decimals after the you want only two numbers after the decimal point, and total of 5 numbers. That's all you want. Okay, so this represents this. 5.2 means this. You have total 5. Okay, you have total 5, and then you are representing two numbers after the decimal point. You want it to be reduced to this floating point number you are getting after calculation to this fashion. But you don't see any numbers over here. It's all small numbers. Okay, so that's why we have used 5.2. If at all we can get more large numbers, it will reduce to this pattern. This pattern it will reduce. Means total 5 numbers and 2 numbers after the decimal point. It's for that. Okay, so for that we are using this. You can remove this and see what is happening. No problem. You can remove this also and see what. Just you say %G. Then you can see what is happening. Okay, you try at your level. No problem. Have you taken the screenshot? Everybody?
Yes, ma'am. Taken.
Okay,
Yes, ma'am.
you can work. So it's already 9:10. Yeah, please execute this. I'll tell you when to leave the meeting. Please start executing this. I may ask you to share the screen. You have to show me how much you have typed. Okay, please execute this.